Hey everybody, my name is Ahmad Nassri. I'm going to be talking to you today about Node.js packaging and some of the modern stuff we're doing today. I work for a company called Mashape. The company is based out of San Francisco. I am out of Toronto and I lead the engineering team. We have people all around the globe: Toronto, San Francisco, Montreal, Spain, London, Netherlands. I think that's it. I might have forgotten some places. We build API tools and products. This is the kind of products we do. This is our team, or at least part of our team. This is in our San Francisco offices. We build API tools for developers to build and consume APIs and allow them to do analytics and documentation of their API tools. These are the kind of clients we serve, so governments, financial institutions, healthcare, and also media companies. They all build their API technology using our tools and products. So I want to talk to you today about JavaScript and specifically Node.js packaging using ECMAScript 2015 and ECMAScript 2016. But before I get into that, I'm going to give you a little bit of history just to get you guys in context. So I want to get to know more about you first. How many people here write Node.js code every day? Cool. I'm running a bit. I've been traveling. I haven't actually been writing code every day for the past few weeks. How many of you guys have actually published packages on NPM? Cool. How many of you guys are running pure ES2016 or 2015 code? Fewer and fewer hands. Okay, interesting. So just a little bit of history about JavaScript in general, ECMAScript in particular, and a little bit about the standardization and where we are today and where we're going. So in case if you're not familiar with it, that's a bad export. I do have some typos in the presentation. I have fixed them while Spencer was talking, so the published one will be fixed. So TC39 is the name of the committee that came together under the ECMA Standards Association, or what are they called? The ECMA International. That's basically an association of, global association of standardization specifically for technology-related standards, and more specifically for programming languages. ECMA 262 is the JavaScript, or more accurately, the ECMAScript standard language spec. So this is the word of ECMAScript, and I use the word ECMAScript a lot rather than JavaScript because ECMAScript is the super spec in which the JavaScript implementation comes from. So this is actually a screen from 2007 of some of the ecosystem of tools and languages and scripts that are actually implementing of ECMAScript. So if you notice, JavaScript is just one little part of it. There's a lot of implementations, a lot of details, and these are all around the same spec, around the same language spec. JavaScript only makes one part of that. So this is all pre-V8, pre-Node.js, pre any of the modern stuff that we're using today. So it's only even bigger today. I didn't find an updated version of this, unfortunately. So the ECMAScript standard came together around 1997. Anything before that, I don't actually care about it. You know the history of Netscape and how JavaScript started and all that. That's all good and well. But it only became an actual standard as a committee came together, all these companies that were working on these languages, and actually came together and sat down and wrote down the spec of what the language should look like in June of 1997. And that was the very first version, and they called it EC1. And then, progressively they continued and added, improvements and changes and updates to the language stack. And in 1998, they updated with EC2. It wasn't nothing major, just mostly updating some of the language and clarification in the spec itself. Then in 1999, December, that was a big change. Lots of features, a lot of functionality was added to the spec. And this is what we, or most of the JavaScript community today, refers to as, in their minds, the core of the JavaScript language. This is what you're dealing with. You're dealing with EC3, which is since 1999. That was when the spec actually was finalized. Fast forward to EC4, that never happened. They were working on that for years after 1999. And due to political issues and kind of differences between all these companies working together, they just couldn't agree on what the language spec should look like. So, fortunately, in 2008, again, think of the timeline, 1999 was the last time an official spec was finalized and published, and then up until 2008, when they finally came together and said, look, all our differences and all our work, we need to kind of get over the differences and harmonize ourselves to actually work on the new version of the spec and improve the language. So that's when they decided to start with EC Harmony. And if you're in the Node.js world, you know that the word harmony or the EC Harmony kind of refers to all these features and functionality in Node.js that weren't actually part of the core and had to manually enable them or transpile to get to them. So EC5 is what we're probably most familiar with in terms of our professional careers, looking around the age groups in our audience here. That's where we all kind of came together and actually started building stuff. It comes down to EC5, where that spec was actually finalized and started to be implemented in browsers. That's what we're actually using day to day. And usually when we're talking about browser compatibility, we're always going back to making sure it works with EC5, which again was in December 2009. From December 2009 till June of 2015, that was last year, no changes on languages actually materialized or happened. A lot of the features, all the functionality that came and went were either in library format or framework format. It wasn't actually finalized into the spec up until last year. So officially as of last year, they stopped the naming convention of ES6 and 7 and so on, and started using the yearly moniker as ES2015. So the current standard is ES2015, and actually as of a few days ago, we're in ES2016. Yay! It's finally official. As what was referred to as ES7, if in case you're using React or doing a lot of that development, you probably heard that ES7 label a lot. So that was actually just finalized recently. And of course there's ES2017, and going forward it's going to be a yearly thing. So every year it's going to be the next spec and the next iteration. So this is all following a new process. There's a new committee after that harmonizing that happened in 2008. A new committee got formed based on new people in the industry from these companies that are involved in that bigger ecosystem, and they now follow a new process, which all of us can now contribute to. It's no longer just a group of people part of a closed community, the elites of the big industry that come together. We can all actually contribute to this, and we start at stage 0. And stage 0 is where you actually have an idea, whatever the idea is. It doesn't matter. Anything you think can actually improve the language itself, as in you want a different methods on an array class, or you want to improve the way you want to do objects in the language, go ahead, suggest it. There's nothing wrong with doing that. As long as you provide proper documentation and proper explanation to what you're trying to solve, it will be considered. Stage 1 is when the committee, the core group, they look at your proposal and say, look, there's something there, there's something meaningful, let's work on it together. And then we'll work with you to actually improve that proposal and make it even better. Stage 2 is when that proposal, having gotten some feedback and some contribution from the rest of the community, actually becomes something more meaty, more solid. It's like, you know what, this is something that would be really valuable to millions of developers around the world. We really need to proceed with this. So you go from a proposal to a draft. A draft is the stage when they need to actually collect more information and validate that this solution is something that's within the realm of the ECMAScript language specification, and it will be useful for a lot of people. Stage 3 is when they finalize that draft and make it public, and they tell the world, look, this is happening. So you start with a small group, yourself or myself, with a core committee at stage 1. People can comment on it, and there's like a few tens of people, not so many. As you progress through the stages, that group becomes bigger and bigger. So when you get to stage 3, at this point, expect that whatever proposal you started is now being already used by millions of people. And I'll get to that a little bit later about transpilers. That means somebody's already using it, and you're going to start seeing feedback about how that proposal actually is used in the real world. If no problems and there's nothing wrong with that proposal and it carries through and people are happy using it, then it becomes a stage 4, which means it's finished. Doesn't mean it's implemented in the spec yet, but it means it's everybody likes it, it's going to happen. When that happens is a different question. So, does that mean I can use ES2016 now? I mean, it's June and they released the spec and it's official and it's out there and the first releases went out and all that fun stuff? Not really. There's a challenge there. As of today, there's not a single engine that is fully compatible with neither ES2015 nor ES2016. So as of today, all the engines are still on EC5. And by engines, I mean the browsers, the Node.js core, which is V8, any of the other the JavaScript server-side or browser-side runners, they all have some sort of engine internally. None of them actually support any of the modern standard. They're all still on EC5. Obviously, if you look at the chart, that's CH51 and OP38. That's actually the Opera browser, or at least the core of the Opera browser. And Node 6 are probably the top of the list in terms of compatibility today. So if you're using Node 6 or using Opera browser, you're most likely to get 90% of that spec available to you in your code. And there's, of course, the link to the compatibility table in case you're not familiar with it. Don't forget as well about long-term support. Even if the language, even if Node.js 7 release tomorrow, and you know what, has 100% compatibility with ES2016. Does that mean you can write modules and packages and release them to the world? No, because the majority of people might still be on the older versions. Not everybody's cutting edge, whether it's like for enterprise reasons or right security reasons or whatever it may be. There is an inherent contract between the community and the maintainers of the language and the tools, and the ES2015 kind of revolves around the LTS periods. And in the case of Node.js, as you can tell, Node.js version 4 will be supported till 2017. And then after that, it will also be in maintenance mode. That doesn't mean it's not being used anymore. And this is just the official support. And as you probably know, other companies will continue to use technologies way beyond the official support period. So again, as you publish packages and write your code, you got to think about, well, will the rest of the community be able to use my stuff or not? But don't fear, you don't have to wait. You don't have to, wait till all these specs are fully implemented or any of that. You can use transpilers. Or in today's world, after having all the other been consolidated away, Babel or Babel, how do you guys pronounce it? Babel or Babel? Babel? Show of hands. Babel? Alright, Babel it is. That's not how I pronounce it. So right now there's really only the one. Like, there were others and there are continuing to be others, but the reality is Babel is is kind of the winner in this scenario. So let's just assume Babel is the way. That said, there are actually a lot more transpilers out there, not just Babel. And even Babel itself is doing things beyond just the core spec. So Babel started as a project called ES5 as in it's just converting from, ES6 to 5, converting from the latest spec to the most compatible one. But it got actually more features and scope added to it beyond just the standard spec. And then all these transpilers start showing up. In the case of CoffeeScript, it was there from before. In the case of some of the others, they're still growing and still being added. And those are just the ones that I found logos for. So there are even way more out there. And what those transpilers or supersets in general, as they're being called right now, are either introducing more functionality to the language beyond the scope of ECMAScript itself, or they're actually inventing a brand new language. So in the case of Dart and a few others, that's a brand new language. In the case of TypeScript and Flow, for example, they're just adding more type checking and more useful features to the language itself that the core script itself is not covered. So ECMAScript doesn't bother with that. In case you missed it, in today's world, as we know, the old trope about JavaScript, that there's a new framework every day, there's a new superset every day now. So keep an eye out for that, because that actually ends up affecting how you publish packages and how you do that. The way that works is, the reason we use transpilers is because we want to make our stuff backward compatible. So if I want to write code in ES2016 today and get advantage of all the new features of the language, that's great for me. But if I'm going to publish my package and share it with other developers, with other teams, with the open source community, how am I going to make it backward compatible? That's the whole premise of the transpilers, or at least that's what they're trying to solve. For me, I follow a typical workflow that makes that job easier for me. First of all, I don't use any other superset languages unless that project is internal and only for my own usage, meaning that I stick to the spec. If I'm going to do something like an NPM module or a library on the share of the world, it might be nice to use TypeScript if it's outside, for example, the Angular community, which is now standardizing around TypeScript. It might be nice, but I want to make it JavaScript agnostic, something that everybody can use. So therefore, for me, that means stick to the script, stick to the standard. And my workflow is very simple. I'm going to share that with you. I use tools, obviously. There's no reason to reinvent the wheel. And there's also a lot of kind of discussion going on today in the JavaScript world of how many tools can there be, and JavaScript fatigue and all that kind of stuff. The reality is the tools are there to help you, they're not there to work against you. And if you use them right and ration their usage, you're not dependent on the tools, you're just making them work for your advantage. So this is my workflow. I run my test, I add my go to GitHub, and I just push my go to GitHub. That's all I do. Now what's actually happening behind the scenes is, I'm going to go back here to this. There's two tools that will be triggered immediately, semantic release and commitism. What those two things do is they listen on my Git commands. When I do a Git commit, commitism is actually triggered there and is doing my commit messages for me. So I don't actually have to write commit messages anymore. So I can tag, I can properly message the type of change that I'm doing in my code. And this is more of a generic tool for writing code in general. It's not very specific to Node.js, but I use that for a purpose. So that when I'm ready to release my package, I don't have to worry about versioning it. I don't have to worry about numbering the version, or is it a patch or a major release or a minor release. That's where semantic release comes in, looks at my commit log, and automatically decides what version to publish. And I'm going to show you how that works. So first thing, in my package.json file, I add all the tools that I need. And then if you notice, I only have two descriptions of the folders that I want to include. There's a source folder and there's a library folder. Again, you can name those whatever. That's what I end up naming. The source folder is where I actually write my modern code. ES2016, ES2015, whatever other kind of superset language you want to create. That's where I write this stuff. Then I use all these tools to actually convert that source code to a compiled language that can actually run on ES5 and other engines. So the first thing I say, I define the engine compatibility that I have in my package. In this case, it's Node.js 10. That's the minimum set for running AC5, really. In terms of long-term support, it's still out there. In case of Babel, I'm using ES2015 as the standard up until, obviously this month is now ES2016, so I can actually upgrade to that. Standard is a tool that actually helps you check the syntax of your code. So in this case, I'm not going to check the output, I just want to check the source. So the source is the source file folder, not the library folder. And commit.json has its own configuration in terms of the type of change log you want to create in your code. I rely on npm scripts. I don't use Gulp, I don't use Grunt or any of that stuff. You can still use that for the purpose of compiling and building your code, or creating the same steps, or maybe perhaps running further tests. But to me, npm script satisfies that need in terms of very simple compiling steps that are needed to publish code to npm. So first thing you'd notice, I have a pre-test step that actually runs standard. So what that means is every time I run that npm test command, standard runs first. And what standard does, it checks the syntax of the language according to a specific set of rules that it needs to check. Comma at the end of the line, semicolon at the end of the line or not. Arrays separated by commas or line breaks, etc., all that kind of stuff. My test step is interesting. So I use a tool called Node.js. If you use Mocha or Jasmine or any other stuff, it's just to get another tool that does that. That's just my preference. You can use yours. If you notice, there's a --node argument. How many of you guys have seen this before? Okay, 1, 2 persons. Great. So what node argument gives you, it's a command line. So this is not Node.js specific. This is, you can run this in the shell or your terminal. It's the same thing. What node argument gives you, it allows you to pass an argument to the engine that's running Node.js. In this case, it's going to be Node.js V8 engine, and add some parameters. In this case, I'm requiring, if we were Node.js, I'm just doing a regular require here. I'm adding a require and passing it the argument of that whole register. So instead of actually writing require, open parentheses, Babel register, close parentheses, in the top of my Node.js file, I can do that in the shell or the command line. What that means is, when I'm committing my code, it can be clean. It doesn't have to include any Babel directives in it. It can be pure ES2016 code. So my GitHub repo, when you look at it, it's just pure ES2016 code. There's no reference to Babel or compiling or any of that. That means the source code can remain kind of pure in a sense. It can also include the polyfill. You can also use this for your own kind of require usage. If you want to just write code that you don't actually want to write the requires in it, or do more directives directly from the command line, you can use the same argument. So this argument becomes very useful for my compiling step and for my testing step. So the test runner, Tab or Mocha or Jasmine, they're not aware of ES2016, they're not aware of the language, they're not aware of the transpiling steps. Some of them have plugins that do that. But this way you can write just pure test in the modern standard, whether it's ES2016 or 2015, and have it pre-compiled and pre-run with Babel. That way your test as well can just remain clean, so you don't have to put your Babel steps inside of your test. And you don't actually have to write a separate compiling step. The compiling step, and in case you wonder, it's not even going to be running in any of my commands here. It's going to be running at the time of publishing. Same thing for the coverage. It's just it's the same as the test. I'm just executing the coverage so I can get some information on that. And then, as I said, the compiling step is just a typical Babel command. There's a pre-publish there that's going to actually run that compile step. And this is where semantic release and code climate trigger. Like I said, in my steps here, I just do the npm test. which in turn will run the pre-test and the test. And when I do the commit, that's just running commit isn't directly, because it puts in the GitHub hooks in the CLI. And from there on, I'm not doing anything. So when I do the git push, that's when the code gets pushed to my repository. At that point, your Travis file or your Circle CI file or whatever continuous integration tool you use will trigger. At that point, I'm actually doing something. I'm running the test, of course, just to get that validation. I'm running it across different versions of Node.js, in this case 4 and 5. I can probably add 6 to this. And then after the success of the test, it starts running some of those scripts that you saw earlier. First, it runs the coverage, so it can generate the coverage file. Then it runs the code climate script, which is just a place where it's going to publish that coverage results. So there's code climate, there's coveralls, there's a few of those services out there. And then the last step will actually run the semantic release step. And the semantic release, in case if you know this, it's going to actually go and look at my commit history, whether you've done a feature change or a refactor or a breaking change, and it's going to determine what version it needs to publish next. And it's going to actually create that change log and actually publish that directly to NPM. So I'm not the one doing the publishing, I'm just writing my code, writing my change log and commit history, and the system is deciding what and when to publish based on the changes that go in there. That's easy, right? That's it. No problem. Okay, but there's a few gotchas. I've actually tried, I made a conscious, stupid decision at first, of rewriting a lot of my popular modules in NPM into ES2015 at the time, and I just published them all. And then the hate started coming in. Everybody was like, your shit is broken, it doesn't work. I even had, one of my libraries was a dependency of request, which is like the HTTP library, you guys probably used it before. I basically broke requests, and it's like the #1 downloaded NPM module in all of NPM. Luckily, people caught it immediately and then messaged me immediately, and I reverted. But I ran into some of these gotchas, so I'm going to share this with you just so you know. First of which is the spec will change. Like I said, you go through all the stages, you go from stage 0 to stage 4, and by stage 4 it's approved. It's going to be in the spec, but that doesn't mean it actually made it to the spec. So this actually happened in ES7. And a lot of people are pretty for using React or similar things. You probably already are using ES7 features. But those are no longer in ES7 because ES7 got closed just a few weeks ago, or a few days ago, and it didn't make it in. So those are actually pushed forward to ES 2017. So a lot of the community members now are actually using these features. They think they're actually going to be in the spec, but they're not, or their code might actually be built assuming that it's going to be there, but they're not there. The compiled API is not going to actually be the same as your source API. So a very simple example of this, if you write classes in ES 2015, don't assume that that API will actually work the same way for Node.js 0.12 users or ES5 users. The actual API will change. Your code will work. And that's what the transpilers promise. They promise that if you transpile your project, it will work and it will function the same way. There might be small notches there, but it will function. But when you're writing a library and you're publishing a library for others to use, you're probably going to write some README and documentation about how to use it. And then people go and actually try to implement that in an older version of Node.js or something different, and it doesn't work for them. A prime example of this is modules. So in ES 2015, there was the concept of actual native modules were introduced. And of course in Node.js, we don't have that yet. We have just a require, or the Node way of doing modules. The problem with that is, if you're transpiling with Babel or any other ones, and you transpile an ES 2015 module, it's going to convert to the whole require syntax. But somebody will go in and try to require it, and it won't work. Because the alternative, the transpiler way, they will add a .default to the module, which you're not using because you're just doing a plain export and import. So your examples won't have that. The developer who's going to be reading the library or using the library is not going to know what to look for. And that was actually what broke the request library when I did it, because I didn't know about that. So I went and found somebody had made a package that's an addition on top of Babel that actually checks if there's a default or not and automatically kind of takes care of it. But that's a big gotcha, and I didn't know about that. So always check the compiled API, even though you've ran your test, even though you ran your unit test, it's not enough. Actually go in and use the library after you published it in an older version. The most most problematic thing about transpilers is performance is just not going to be there. Especially if you're running on something like Node.js 6 and getting all this stuff natively in the engine itself, but then try to run it on a Node.js 4 or a Node.js 12 or any other engine for that matter, the performance is not going to be the same, and you need to realize that. And again, this is one of the problems I've had with my libraries. I benchmark it works amazing, it's great, but then somebody else is using it as a dependency in their project, and it's slowing down their project. So it went from a very efficient library to a very negative effect on that project because of that change in the transpiling process. Because the transpilers are not optimizing the code. They're optimizing the code for their own usage, but they're not optimizing the code for what your library is trying to do. So you are not able to go into the code itself and actually do some optimization of your code for performance basis. A lot of the transpilers are not able to do native features. All they're actually able to do at this point is sugar. They're just adding syntax sugar to the language. Some of the actual features of introducing the specs of ES2015 and 16 are actually in the core of the engine, and they cannot be done with a transpiler. So you might be limited in that regard, or especially if you're writing code for Node.js 6 and think that you're actually going to get a full 100% coverage of back to ES5 with Babel or otherwise, you're not always going to get that. So check the feature that you're implementing and using, make sure that's something the transpiler will cover. And don't forget, as the story goes with a lot of open source project, eventually they'll either get abandoned or the core maintainer will lose interest, or it won't be as cool anymore. There'll be a new cool library, new cool transpiler. So be careful of abandonware. Eventually all the tools will decay and the ecosystem will become fragile. It's just, Babel is not going to be there forever. It's just not. Look at the history of any of the languages and tools and frameworks we used in the past. They're no longer here today, or they completely changed, or they're no longer as important to our workflow as they were in the past. The other side of the problem, if it's not pure technical, is operational. So when you are relying on so many tools to actually create a project that's backward compatible, that can be shared with the rest of the community, that can be an open source module, or even just a commercial module for that matter, it's very tooling heavy, it's very tool independent. Meaning that you may have configured in your system and got it all working, but think of the other person who's running Windows. Think of the other person who's running Linux. Think of the other person who's running a whole different version of everything and a completely different environment. It might actually take them a full day just to configure the build process. Never mind actually getting the thing to work. So that's a big investment. So realize that when you are relying on so many tools, there's an investment cost associated with that, not just for yourself, but also for everybody else who has to do this. So if you're working in a company or a team or build everything in modern languages or modern specs, there's a team of 20, that means that investment has to be times 20. Even if you use things like virtualization and centralized dependencies, you still have to set all that up and make all that happen. But don't worry, it gets better. In fact, it is better. If you think back to, I don't know, 5 years ago, JavaScript wasn't really as powerful as it is today. We didn't do as many things with JavaScript, Node.js even, as much as we do today. Today you're doing things with wearable technology, IoT, server side, browser side, all these things. It's actually getting better. And it's gotten better because of the community coming together, harmonizing, and actually improving the language as a whole. So it actually will be even better if you contribute. So actually take the time and go through the specs, understand how these committees work, understand how these people are trying to do their best to improve the core language that you're using, and actually contribute back. And contribution doesn't have to be you going and writing a whole new feature stack of the language. No, it can just be finding a typo on the documentation, telling them, hey, you got a typo. It could just be introducing an idea or finding a bug and telling them about it. That's contribution. But if you're dealing with an issue in your project and it's something that you're struggling with, and you make your own work around it and just move on, the community may come across that same problem or same challenge, and they're not going to get the benefit of what you learned. So this is where the open source community comes together, and you can actually contribute to that and make it all better. Thank you. Like I said, I'm going to upload those slides on my website, but also if you're interested, I made an NPM package generator that basically does all of these things that I just talked about, plus a little bit more. It is a little bit outdated, so it might be a bit buggy, but I use it every time I want to create a new package. Would love for you guys to contribute. Share it, fork it, make your own version, use different tools, let me know what works. I also want to point out TechMasters Chat is a great online Slack community in Toronto. We have over 1,200 members. We talk about all sort of programming things and technology. Join it, it's free, it's open. I'm also on Node School Toronto. We mentor and share and teach people how to use Node.js. Love for you to join us, even if you're already an expert, you also have things to learn, or if you just want to mentor and help other people, come join us. Full Stack Toronto is happening, I think in October. I forgot, it's a full stack conference in Toronto. If you guys haven't heard about it, check it out. Lots of global speakers and speakers from all around the world coming to talk about everything in technology, just full stack. Any questions?
So you mentioned you benchmark your own module. What tools are you using?
Benchmark.js for the most part, but my mistake was that I benchmarked it just with the engine that I was running. So I had, I think it was Node.js 5 at the time, and I was just benchmarking against Node.js and did all of that, and it looked great. But then the people who were running it, they're running it against 0.12, and that just did not translate at all. Go ahead.
You publish your package using the ES2016. Do you still keep the copy of the source code as well? Do you make the copy of the source code? Because let's say somebody wants to work on your module, how would they do that?
So the question is, if you write a package in ES2016, do you also package the source code as well? That's where that directive there basically says, I have two folders to be included in the package. So when it's published, it's including the source folder and the library folder. So if somebody is already doing their own ES2016 thing, they can just not worry about the slash library of my module. They can just go straight to the source. So they have their own compilation step. That's all great and well. And I usually just write that in the README as well, indicating that if you're doing your own thing with compiling, here's the source. But if you don't want to deal with that, it's already pre-compiled, so you're good. I'm going to go back here because we'll have the next. Any more questions?
Where's the slides?
It's going to be on the website. I haven't uploaded it yet, but I'll upload it. I'll also tweet it after with the hashtag, so you guys will see. Go ahead.
Does anybody consider like a conditional main for whether or not you're running ES5 or ES2016? Let's say I just want to deploy your ES2016 code instead of whatever transpile.
Let me try to repeat the question. Is there a way to do conditional main? There is a Babel extension that's specifically trying to do that. I tried it. And the idea there is that, okay, so I create my package, I publish it, whether it's through GitHub or NPM, and people can download it. But then depending on the environment they're running their code on, there's some sort of condition that can check and choose what's best, right? Because let's face it, you can do NPM install of a package, and if it comes with a source, why would you want to have the compiled version? Because that's just like X amount more lines of code and potentially bad performance, right? So it's a good question. It's not done very cleanly, and I have not seen it done very cleanly. I even tried and attempted to do something myself, like creating a tool that does that. Ultimately, it comes down to you, the developer, to watch your implementation. When you're downloading packages, check if there's a source of them. Rather than running the compiled version, run the source. That's even better. In a lot of cases, it's worse because the source package might be something like CoffeeScript. You're not going to be able to avoid that because if you get the source, but it's not useful for you. So you have to do either two compilation steps to do the CoffeeScript your way, or you have to rely on the compiled version and hope the performance is good enough. Any more questions? All right, thank you guys.